this evening. Uh, Let me share my screen and let's get started. All right. So my name is Ahmed Sharif. I'm a cloud delivery manager at DataKite. We build solutions for banks, AI solutions for banks. I'm also a Google Cloud authorized trainer and GDG lead for GDG Amman in Jordan. And I'm more than happy to be with you today here and share my expertise about BigQuery and BigQuery ML. So today we'll be moving from the raw form of data that can be stored in a database or a dataset or call it whatever you want, maybe an Excel sheet or whatever it is. We're going from this form to something that can immediately make decisions. Let's take a dive deep. We'll be talking about machine learning with BigQuery ML. But before that, we need to have an idea about BigQuery and a broader idea about datasets and databases and these stuff. So we'll be talking about the concept of data warehousing. We'll jump into Google BigQuery as a Google Cloud product where we can analyze our data. After that, we'll take a look at machine learning options on Google Cloud. And finally, we'll take a look at BigQuery ML, and we'll have the chance to experiment with it through a lab. So let's get started. When I say a data warehouse, it's simply a place where I store my data, just like a database, just like a desk, just like everything. But to understand what exactly a data warehouse, we need to understand the data itself. Data is simply the digital footprint generated by every user interaction, system process, or API call, or sensor reading. Any footprint, any trace that any system or any event that's recorded, it's called data. And we treat data as treasure these days because we can simply understand the world around us just by recording data and understanding it. So the data will be the building blocks here. We're going to build our data warehouse with data. Okay, so data is a collection of facts, figures, or observations. Observations if we're talking about an IoT device that's recording, or a meter that tracks the speed of the cars on a highway. It can be structured or unstructured. If it's structured, simply it has a format. We have a predefined format, a table, or a form that we already know, and we just record this data and organize it within this structure. But when it's unstructured, simply we don't have a predefined format. It can be any form, but still it has a meaning. And data in its raw form often lacks meaning. So if I don't process the data, if I don't organize the data in any form, simply I can't say it has a meaning. It's just gonna be numbers, text, images, but I can't say this is something that I can ground on, or I can say this is a fact. Every single day since let's say the rise of the internet as something that we use every single day, we've been seeing our data accumulation going up in this format. We're talking about, like these days, we're talking about 180 zettabytes every single day. By the way, a zettabyte is a billion terabytes. That's a lot of data. So that's a lot of data to deal with. And we need a place that we can store, a place where we can process and analyze these data. And this is where the majority of the computing systems around the world are working. So the first place where I can take my data after collecting it is the database. I think everyone is familiar with the idea of a database. A database is a place where we can electronically store these collections of facts or the data, but in a structured format. So simply, we have a schema, we have rules that governs how the data is going to be organized in that place. And we can rapidly access, manage, and update these data nodes. So when I go to an ATM and do a withdrawal, the ATM is going to give me some pounds and it's going to go to the database, a record that Ahmed has took some money. And these money are, let's say, 100 pounds. When I go to Amazon and I do a purchase, it's going to be recorded somewhere in a database in a bank. And databases generally are optimized for online transaction processing, or OLTP. We'll get to that later. The other way of storing and organizing our data is the data warehouse. And this is where BigQuery is coming. A data warehouse is a centralized repository, like a place where we bring all the data from various sources. But this data has a structure too. And the data warehouse in its design is optimized for online analytical processing, or simply for analytics, not for fast transactions, not for transactional systems or these stuff. The main reason of having data warehouses is to store massive amounts of data and perform analysis instead of making a lot of writes to or changes on data. Okay, so the foundational characteristics of data when it's stored in a data warehouse. Generally, it's subject-oriented, so the data is organized around a specific business subject. Simply, the history of taxi rides in New York City. Every meter, every taxi in New York City, recording the trips that has been taken. That's a subject or business subject. But when I say a bank database, it's object-oriented, or the data is a bit objective. The main purpose is to organize the data and get it very fast, instead of this data is stored there for the sake of a specific business subject. Integrated. A data warehouse acts as a single source of truth. In modern systems, we can have multiple databases, but generally we tend to have a single data warehouse because this is the place that all of our data is going to go there for analytics. Time variant. The data in a data warehouse, it must be time-stamped or telling a specific story about the business subject that we're talking about. So if the data does not have like a timestamp or a time period that describes a certain event, it's useless. Even if it's organized in a data warehouse, it's useless. The last point, non-volatile. Data in a data warehouse is generally strictly read-only, which means when I write data into a data warehouse, I won't be making a lot of changes on it because the data is already processed, already collected, organized. The purpose of bringing data into a data warehouse is for analytics, just to understand the data further. solving problems, making decisions. And this is where we'll be talking next, the decision making out of this data. Okay, moving to the modern data warehouse, and this is the family of BigQuery. Simply, we will be solving modern business problems by implementing a data warehouse solution on the cloud. In the old days, data warehouses were limited by the compute power that the on-premises servers used to offer, or the expertise that were in in a certain business. But these days, everyone can have access to a modern data warehouse. You don't need to purchase a certain hardware or have a very specialized expertise to just have a data warehouse and perform analytics on your data. Everyone can get it through the cloud. Okay, so generally, a data warehouse should always consolidate data from many sources, even the databases within the systems of a certain company. Everything should be brought into the data warehouse. This is where we'll be performing our analytics. So we need to have all the data, all the raw data, all the pieces and events that have been happening to understand the full picture by performing analytics. And the data in a warehouse should be consistent and accurate. I can't just say, we have some sensors reading data about the weather somewhere in A6 and say, okay, we can use it for analytics. I'm not sure if the IoT devices are trustworthy. So it has to be accurate. It has to be consistent in order to make decisions based on this data. The last thing, a data warehouse should be optimized for simplicity of access. This is a very important point. The structure of data within a data warehouse is a bit different than what we used to in the SQL databases, where the tables are highly normalized, everything is strongly relational. In data warehouses, we simplify and denormalize the data in order to get faster analytics and faster decisions. Also, data warehouses should also be optimized for high-speed query performance. Imagine being a data analyst, but you run a query and you need to grab lunch before it's done. The decision or the insight that you are trying to find might by then lost its value. Imagine that. So it has to be very fast. And this is what modern data warehouses brings to us. And that's exactly what BigQuery can do. BigQuery is a product from Google Cloud that is fully managed, which means we don't need to manage any infrastructure, any configurations. All we have to do is start using the data warehouse, start performing data analytics. It's serverless and enterprise grade. When we say serverless, no need to provision any servers. Google will provision the servers to execute your command or execute your query, and we're going to see that in the demo. And after that, it's going to take these resources and provision them to someone else. Enterprise grade because it simply can serve massive scale of data. It's designed to ingest, store, and analyze massive amount of data, as I mentioned before, and with incredible speed. We can get the answers within a few seconds. Not minutes, not hours, not a weekend. Okay. General features about BigQuery. It's a huge solution, but today we'll be just focusing on the machine learning part of it. So it can handle petabytes of data. You can store petabyte of data and perform analytics on them. It's serverless, and it has a strong ecosystem for ETLs and data processing tools. It has machine learning capabilities, and this is what we are talking about today. And it supports a very strong security and collaboration capabilities. What's great about BigQuery is that the data is stored in a redundant way, separate from the compute. So our data will be stored on distributed storage on multiple places, for example, in 3 data centers in the UK. And whenever we need compute power, whenever we need to perform analytics on this data, Google will give us compute power to execute these queries. So simply, we'll be adding data or ingesting data, as we see on the most left. We'll be ingesting data into this distributed storage, and whenever we need to perform queries, Google will give us compute to perform that. And this happens seamlessly. It supports SQL. So if you can use SQL, you can do any form of analytics you want on BigQuery. Also, you can build machine learning models. It supports REST APIs, and it has web UI and CLI interfaces. So if your software or your code needs to perform analytics, you can do that through the REST API. If you are a data analyst who just want to access a user-friendly UI, we go to the web UI, which we'll be using today. You can also do CLI. Not everyone do it, but it's possible. And it supports 7 client libraries as of today. So if you use Python, Java, wherever you, or Go and other languages, you can have your code interact with BigQuery seamlessly. So simply, wherever your resources you need, it's going to be allocated to you. And if the demand fades out, the allocation will go, and we will be just paying for what we use. Okay. The main reason of using BigQuery is to analyze data and gain insights. So we can ingest petabytes of data in variant formats into BigQuery, and that's the first step. We can perform in-place transformation on this data through EL. And this way, if we are coming from machine learning background, we'll be simply preparing our data for machine learning. So we can prepare our features in BigQuery using standard SQL. After that, we can store this data for an extended period of time inexpensively. It's so cheap if we look at it. We can perform at any scale derived analysis and gain insights. Finally, we can do visualization through Looker and LookML. So these were the main features of BigQuery, but we'll be focusing now on the machine learning part, the machine learning on Google Cloud. So Google Cloud offers us with 4 options to train machine learning models on its infrastructure. The first thing is the pre-trained APIs. The Vision API, the text-to-speech API, all of these are pre-trained machine learning models that Google provides to us just to use. We can't do major edits or changes. We can just use AI capabilities on machine learning models that Google offers as APIs. The second option, which is the the most sophisticated one, BigQuery ML, we can use only SQL queries to create and execute machine learning models in BigQuery. The third option is AutoML. If we don't want to write any form of code, we can go to Vertex AI, use AutoML to train machine learning models. The fourth option, if we need unlimited flexibility in terms of our training process, we can go to the custom training. But here we'll need some expertise in Python, PyTorch, TensorFlow, and those platforms and frameworks. So our focus today as, let's say, data analysts will be on BigQuery ML. We'll be using SQL to process data first on BigQuery, and after that, create machine learning models. In custom machine learning, whether it's in Google Cloud or you do it on your own computer or on any other platform, generally we need to go through these 7 steps. We need to identify a problem. We need to import and pre-process the data. So here we'll be doing some data science work. We need to split the data properly for training, for testing, and for evaluation. We need to build the model. We need to train and evaluate the model. And after that, we need to deploy this model and activate it within a software or application or something like that. And finally, make predictions, actually make use of this model. But it can be easier. We can simply just identify a problem and gather the data somewhere we've been talking about lately, train the model and evaluate it immediately, and after that, make predictions. I think this looks better, no? I'm talking about BigQuery ML. BigQuery ML will help us go from this to this. All right. So we will be using SQL to invoke the machine learning model training on our structured data. We need to gather the data somewhere in BigQuery. Write SQL queries that's going to invoke the machine learning training. And this way, we'll be helping our businesses make decisions based on predictive analytics, not just insights. More importantly, and this is very important for businesses that has sensitive data, when we use BigQuery ML, we don't need to export the data out of BigQuery. So we can train our models in place wherever the data is stored, which is in BigQuery, the model is going to be trained there. And that's amazing if we think about it. From compliance, from security perspective, it's amazing. Simply, you don't have to move the data to a machine in order to perform the training. Okay, so how we work with BigQuery ML, we're going to go through these 4 steps. But let's do that in a lab. If everyone have access to Google Skills, you can do it with me. I've shared the lab URL here in the chat box. You can go there and start the lab. If you'd like just to watch, feel free to do that. All right, so we'll be having our data in a data set in BigQuery. We're going to invoke the create model query to create a certain model on our data. After that, we'll be evaluating this model through ml.evaluate and then the model name. And finally, we'll be able to make predictions or use this model still in BigQuery through the ml.predict query. So In this lab, we'll be going through these steps. Let me change my screen to take a look at the lab. So here we'll be making predictions on taxi fare for multiple rides within New York City. It's a very popular data set that a lot of data scientists use to just build skills. So I'm going to go and start the lab here. As you can see here on the right, we have multiple tasks to perform. We're gonna do some of them. So we'll be exploring the data first. We're gonna identify the objective. We're gonna select the proper features that we're gonna use to train our model on. After that, we're gonna create the model we'll be creating a data set within BigQuery. We're gonna select the right model type for our problem and build a model based on it. We're going to evaluate this model and we're going to make predictions on it. So let me go and open an incognito window. Now, Google Skills is taking me to a sandbox environment where I can perform these tasks without paying anything or without be using my own account. Okay, so this is the Google Cloud dashboard. We're gonna start with going to BigQuery. We can simply search here for BigQuery, or from the side here, we can find BigQuery too. So here, this is BigQuery Studio. This is the user interface or the web UI version of BigQuery. Here we have a lot of features for BigQuery where we can build data pipelines, we can perform data governance practices and apply policies in order to protect our data here on the side. Also, we have administration tools, maybe to monitor our data where it resides. We have disaster recovery features and tools. We have migration service, and these are generally more of a BigQuery specific than BigQuery ML specific tools, because BigQuery, if you look at it, it's a complete suite of tools that you can use it to deal with your data warehouse. So here we can run our queries, as you can see, and we can have multiple tabs. Okay, so let's take a look at the dataset that we'll be using. It's a public dataset. So it's standard SQL. We'll be selecting data in a certain in a certain let's say month, and BigQuery will go to the main dataset and retrieve data and execute this let's say query. As you can see here, we can see how many trips in New York City has been happening in every month in 2015. So here we can take a look at a sample of our data after the processing. Let's execute another query, but for a different question. Okay, another question. What was the average speed of Yellow Taxi in 2015? That's another question. And as you can see, here we're performing normal SQL in order to calculate that from the data. So I'm gonna hit run and see the result. Okay, it seems to be there's an issue here with the query validation. Okay. As we can see here, the results shows the average speed in every hour for that year. So from analytical perspective, we can answer a lot of questions here. Okay. Now let's identify the objective of the machine learning model that we're gonna build on this historical data. Here we have we've seen the data set, the data that we have, the trips that have been happening in New York City in that year. And the objective now is to predict the price of a cab ride in New York City based on that data. So we need to train, obviously, a machine learning model. Let's take a look at the features first. I'm gonna go here, run this query in order to see some of the features within this data set. Okay, so here we have the total fare from that data set and the day of week when was this trip happen, the hour of day, obviously this data from midnight, the pickup location, here it's described as latitude and longitude, also the drop-off location, and the number of passengers. I think these are useful features to consider for our machine learning model. One of the most important factors when we consider predicting the total fare of a trip, whether it's in London, in Amman, or in New York City, is whether it's weekend or not, what is the day of week? Is it in the midnight, so it has a special fare, or it's a peak hour, or it's just another time of the day. The time the time of the trip and the pickup location and the distance that we took throughout this trip, all these things are important, and everything and all of these I can consider them as features to train my model based on. So I'm gonna go and create a dataset, and this dataset will be the home for my machine learning model. So I'm gonna go here. This is the project ID. I'm gonna hit create dataset. Here I'm gonna give it an ID. It has to be a special name within the project. Here we're gonna choose the location where this data will reside. As you can see, we have US and Europe as of now. I think there is other options if we were out of the lab environment. I'm gonna go for the US. And after that, I'm gonna hit create dataset. Now I have a dataset where I'll be storing my machine learning model after creation. So let's go here and create a new query. And this query will be to train the model. What we're trying to do here is to create a model that can predict the total fare of a certain ride. So if we look at it from machine learning perspective, it's linear regression problem. It's not a classification problem. I'm not trying to classify an image, whether it's a cat or a dog. I'm trying here to solve a sort of a regression problem where it's more bound to numerical data. So we'll be using the create or replace query to create a model. We're going to name it a taxi fare model. Here we're going to set options. The first thing is model type. It's going to be linear reg or linear regression. The label is going to be total fare, which is what I'm trying to actually know or understand. And here I'll be defining my parameters. So here, these are my features, the day names, the taxi trips. I'm going to do some transformation on this features in order to ensure that the model does not have wrong inputs that's going to lead to a disaster with the output. So now that I have everything set, and here we have the we're simply bringing the data from the dataset, and we have here some restrictions in order to take a sample of this data. This dataset is huge. We're talking about 10 million records, and that's a lot of data. We'll be training a very small model. So right now, BigQuery is executing the training process. Here we can see the job information, a lot of metadata and details about this job. Here we have the execution details, the elapsed time, and how long the execution has been happening. And if we go here, we're going to see a very interesting graph. This is going to show us the steps and more details about these steps as they happen. So here we're still in the validation or the validate step. Okay, BigQuery went a bit faster, but as we can see here, we have the validate, then the pre-process, where BigQuery will be preparing the features to be included in the training, and after that, the training process, and after that, the evaluation step. We'll be evaluating the model within within the execution time. So now that we have the model ready, let's go to the model and see some details about it. Here we have the model type, linear regression, the model ID, and more details about it. And here we have the features that we have included within this model. As you can see, we have the day of week, hour of day, the backup and drop-off location, and the passengers. And here we have the predicted total fare, which is the output of this model. Okay, so now that we have the model ready, we're going to go and execute another step, which is very important when we are training a model. We'll be evaluating this model. Here, we'll be calculating the mean squared error for this model. This is a very important metric that we rely on when evaluating machine learning models. So I'm going to run this query, and here we can see the RMSE of this model, the root mean squared error. Now that we have evaluated this model, we're going to go and make predictions on this model. We're going to use ml.predict query, ml.predict. We'll be using our model, the taxi fare model, to make predictions on this model. So here we'll be specifying the features again, because it has to be in a format that the model can understand. Okay, so I'm gonna go here and hit run. We'll be taking a sample of this data and using it to make predictions. And now we have 50 predictions on some data from this dataset. As we can see here, we have the total fare, the actual total fare of this trip, and we have the predicted total fare. And as you can see, there is like a massive gap. Imagine the actual trip was here, let's say $15.5, but the model has predicted it as 11.64. That's almost $4 difference. So there's a lot of stuff that we can do to optimize our models. So maybe we can improve the features. We can do feature engineering, and we can do that simply with BigQuery ML. So I'm gonna retrain the model again here, but with more feature engineering, with more changes performed and transformations performed on the features to make them more meaningful. So let's retrain this model. Here we'll be training a new model. We called it Taxify Model 2. It's again a linear regression model. This time is going to take a bit longer because this time there will be more data pre-processing to be performed. Okay, so our new model is ready. And as you can see here, we have some details about it. And let's recalculate the root squared error of this model. We'll be using ml.evaluate again to evaluate the new model. As you can see here, this time the RMSE is almost the half of the last time. Last time it was like 9, but this time it's 5, which takes us to a better model. All right, so we took a look on how we extracted and transformed and loaded data into BigQuery. We've done that from a public dataset. We've selected and pre-processed features using standard SQL. We've used create model query in order to create and train a machine learning model within BigQuery. And after that, we've used ml.evaluate to evaluate our model and calculate the root mean squared error. And after that, we've made predictions on this model, and we've optimized the model by performing some feature engineering using the using standard SQL. So BigQuery ML supports multiple machine learning problems. It's not just for predictions. So simply we can do logistic regression, which is a classification problem. We can do DNN classifier. We can solve for XGBoost problems. Also, it supports MLOps features. So simply we can automate the process of training and retraining, evaluating, and activating our models. Also, we can solve for key mean clustering, anomaly detection, and various machine learning problems. Uh, so now we went from a data warehouse to AI within our platform, BigQuery. So thank you very much for your time today. And if anyone have any question, feel free to ask me. You may raise your hand and unmute yourself, or simply leave the question in chat so we can answer it. Yes, Sandra, go ahead and unmute yourself.
Sandra, you need to unmute your mic, please. Then you should talk.
Okay. Yeah. I think she can't unmute herself. Okay. If you may leave the question here in the chat box, and I'm gonna read it and answer immediately. Hi. Will the slides be shared with us? Sure. I can share them with Ahmad, and he can go ahead and share over email with you, if that possible, of course, Muhammad.
Yes, I will share the slide when I get it. Thank you very much.
Perfect.
Thank you, Ahmed Ashraf. I think there is no question. Thank you for your great presentation. I think my attendees are so inspired to get it. I would like to request to everyone who actually joined this event, try to connect or create account with Google Skill. Okay. Also, try to join the Google Archive program. Okay, that will give you the extra free credit and very special and interactive lab you can perform, and you can dirty your hand with the Google Cloud Sandbox account. Okay, and thank you joining with us. Thank you, Ahmed Ashraf, for your insight and your great presentation indeed.
Absolutely, Muhammad. Thank you. We have Sandra's question, but before we leave, so Sandra's saying, I've been working with all companies. They are afraid of sharing their data with cloud solutions, as they think this data can be compromised. Is Google able to access and see this data once is in the cloud? Um, in Europe, this is not possible because all of the cloud providers, including Google Cloud, they cannot access or see the customer's data or make use of it. So, uh, if it's sensitive data with proper data setup, let's say, or uh, data protection setup within Google Cloud, every company can ensure that their data can never be compromised on the cloud. And for the let's say highly sensitive data, there is a solution called BigQuery Omni, where you can run BigQuery on premises. So this might be useful for companies where with highly sensitive data. Absolutely, Sandra.
Yes, it is correct, Ashraf, because Google can't see the customer data because there is a European Union law that will prevent to them. I hope Bagami got to the answer. There is any other question? I don't think so. No. Thank you very much.
Okay, there's another question.
Oh,
Yeah.
okay.
Is it possible for another session that connects BigQuery ML models with live agents as APIs? This is for you, Muhammad, I think.
Yes, I give your answer. I will try to arrange the success session. And I want to give you one information. In the backend, I am working to very insightful organizing the session based on the database or based on different type of profession like perspectives of data scientist, data engineer, or data architect, or cloud architect, or DevOps solution operational management, this kind of point of view. So you will get it very soon. To stay touch with our event phase, you will get the update, become the member, okay? And also, I have your email address. If I organize this session, I will invite you. Thank you very much.
Perfect. Thank you very much for your time, everyone, and I hope I see you again.
Okay.
Have a
Thank
good
you.
night.
Thank you, everyone. And don't forget to leave your feedback after finish this session. You will receive our feedback form. Please leave your feedbacks for us so that we can organize a good event for you. Thank you very much.